For our discussion forum this week, we're going to again practice with some online technology. This app that we're going to use is called GeoGebra. We're going to use the GeoGebra web app. It's going to help us not only graph a function, but also locate the absolute max and minimum values on a closed interval. We're working on page 312, and I'm going to use GeoGebra to help me do problem 3 here as an example, and then for the assignment you'll be working on problem 5. So I just wanted to show you that before I switched over to the web page. So when you access the web page, you should see a screen that looks like this. This is the GeoGebra web app, and you'll see over here there's a graphics view which will graph our functions for us and plot our points and things like that. You can use the Move tool, which is located up here, Move Graphics View, to move it around and look at different areas of your graph. If you right-click on the region, you can also show the grid, which is nice. You know, it gives you a graph paper feel, and it helps us zero in on particular points on a graph. Over here on the left, this is where our objects will show up as we enter them. So keep an eye on this left-hand side after you're typing to see where your objects show up. For problem 3, we need to enter function f of x, and you literally just type f of x equals. Now this is a rational function with a fraction, and for these calculator computer type entries we want to keep the numerator and denominator in parentheses. So my numerator, I'm going to start with parentheses. You'll notice it automatically gives me 2 parentheses when I type 1. I'm going to type in 2x cubed minus 3x squared plus 1, that's the numerator. I slide over and hit the division symbol, and then parentheses for the denominator, x squared plus 2x minus 8. There's my rational function. If I hit enter, I get a graph of the function. Now this is an interesting function. It has an interesting asymptote over here between 1 and 2, and it breaks the graph into 2 pieces. And while it's interesting, unfortunately, it's not really something we're worried about, because remember, we're only concerned with the graph from -3 to +1. So just to send that point home, I'm going to add a couple of extra objects to this picture. I'm going to graph x equals -3, which is my left-hand boundary, and x equals 1, which is my right-hand boundary. That'll help me focus on the portion of this graph that just is included between those two x values. Now, this interval actually moves way up here to the top of this picture, and so we don't really get them all in the picture right now. What we can do is reset the graphics view using this ratio tool here, and if I change it to like 1 to 5, you'll notice that now I can see the top of the graph in that interval. The graph starts here, comes down, looks like it drops below the x-axis a little bit, then comes back up right there. I've changed the ratio, so now I can zoom in to get a better picture. Ooh, that might be too much. Let's zoom out just a tad. And then you can slide it around with the Move tool again just to kind of get it so we can see all the pieces. So here it is. It starts here, moves down underneath the x-axis, and then stops here at 1. This is the only piece we're concerned about. So I have an idea of what the graph looks like on the interval, but what about the absolute maximum and minimum? Well, that's where GeoGebra comes in. If you go back down to your input line and type max, you'll see that several max functions show up, max commands. And the one we want is the top one, which will give us the maximum on a closed interval. We type the function in, the left-hand value or start value, and then the end value, which is the right-hand value. So I'm going to select that. For function, you'll see it's highlighted. I simply type f of x because that's the name of our function. Right here. Right here. If I hit tab again, get out of the way. I type in -3, and if I hit tab again, I type in 1. So this will give us the maximum on that interval. And our maximum is located at -316. You see letter A shows up. That's the maximum on the interval. Right? And that makes sense because it's the highest point, right? It's the highest y value at 16 on this little interval here. It looks like the lowest one is down here somewhere. To zero in on that, we use the minimum function. So I type min. The top one pops up, which is the one I want. My function's f of x. I tab. And my start value is still -3 because that's the left-hand boundary of our interval. And I tab again and type in the right-hand boundary, which is 1. If I hit enter, another point pops up. This is letter B. This is our minimum value on the curve. Drops just below the x-axis there. In fact, it's 0.05, comma, -0.13. The lowest y value on the interval happens to be -0.13, which is right here. Okay, so here we have a picture which shows our graph on the interval. We've located the max and min values using the max function and the min function, and those values are even given to us over here on the left-hand side in our object list. That's what we're looking for, and then you can just go ahead and make a screenshot and post this in the discussion forum. If you have any other questions, please either post them here or even drop me an email if you need to. All right, good luck.